The Continental Drift. The continental land drift continued. The Earth's core had become as dense and rigid as steel, being subjected to a pressure of almost 25,000 tons to the square inch. And owing to the enormous gravity pressure, it was and still is very hot in the deep interior. The temperature increases from the surface downward until at the center it is slightly above the surface temperature of the Sun. The outer 1,000 miles of the Earth's mass consist principally of different kinds of rock. Underneath are the denser and heavier metallic elements. Throughout the early and pre-atmospheric ages, the world was so nearly fluid in its molten and highly heated state that the heavier metals sank deep into the interior. Those found near the surface today represent the exudate of ancient volcanoes, later and extensive lava flows, and the more recent meteoric deposits. The outer crust was about 40 miles thick. This outer shell was supported by and rested directly upon a molten sea of basalt of varying thickness, a mobile layer of molten lava held under high pressure but always tending to flow hither and yon in equalization of shifting planetary pressures, thereby tending to stabilize the Earth's crust. Even today, the continents continue to float upon this non-crystallized, cushiony sea of molten basalt. Were it not for this protective condition, the more severe earthquakes would literally shake the world to pieces. Earthquakes are caused by sliding and shifting of the solid outer crust, and not by volcanoes. The lava layers of the Earth's crust, when cooled, form granite. The average density of Urantia is a little more than 5½ times that of water. The density of granite is less than 3 times that of water. The Earth's core is 12 times as dense as water. The sea bottoms are more dense than the land masses, and this is what keeps the continents above water. When the sea bottoms are extruded above the sea level, they are found to consist largely of basalt, a form of lava considerably heavier than the granite of the land masses. Again, if the continents were not lighter than the ocean beds, gravity would draw the edges of the oceans up onto the land, but such phenomena are not observable. The weight of the oceans is also a factor in the increase of pressure on the seabeds. The lower but comparatively heavier ocean beds, plus the weight of the overlying water, approximate the weight of the higher but much lighter continents. But all continents tend to creep into the oceans. The continental pressure at ocean bottom levels is about 20,000 pounds to the square inch. That is, this would be the pressure of a continental mass standing 15,000 feet above the ocean floor. The ocean floor water pressure is only about 5,000 pounds to the square inch. These differential pressures tend to cause the continents to slide toward the ocean beds. Depression of the ocean bottom during the pre-life ages had upthrust a solitary continental landmass to such a height that its lateral pressure tended to cause the eastern, western, and southern fringes to slide downhill over the underlying semi-viscous lava beds into the waters of the surrounding Pacific Ocean. This so fully compensated the continental pressure that a wide break did not occur on the eastern shore of this ancient Asiatic continent, but ever since has that eastern coastline hovered over the precipice of its adjoining oceanic depths, threatening to slide into a watery grave.